Hi, this is Mr. Max with Sankofa Mathematics. It's been a while since I have done some of these videos, so I'm going to start by doing word problems involving equations. So this is like for grade 10, 11, and even grade 9 learners can benefit from this information. Okay, so I'm going to start right off. I've got about 14 questions on this particular topic or cycle. So I'm going to start right from question 1. Okay, so the first one says the sum of 4 consecutive numbers. So consecutive numbers, integers. So the first one, let it be like x. The next one should be x plus 1, then x plus 2, then x plus 3. So check, if I start with a number like 4, then the next one will be 4 plus 1, the next one will be 4 plus 2, and 4 plus 3. And you will see that these numbers, they follow each other. So that is now why I'm using the x, because we don't know quite what that number is. Okay, bottom line is, if we add them, if we add these things, they should give us 50. So that means it's 4x plus 6 equals to 50. And so you go ahead then and you solve this equation. Okay, so you will be seeing that the value of x is nothing but 11. So the largest one of them, so the largest would therefore be 11 plus 3, which in this case is 14. Good. The second question, John thinks of a number, so we don't know what the number is, so let this represent by x. He adds 3 to the number. He multiplies the results by 4, and then he gets an answer of 10. So you can go ahead and you can solve this particular equation. So that's 4x plus 12 is equal to 10. So 4x is equal to 10. Take away 12. 4x is equal to negative 2. Then x is negative 2 divided by 4. Therefore, x should be negative 1/2 if we simplify that fraction. Okay, find two numbers whose sum and whose difference is 12. So when you add these two numbers, you're going to get 12 as an answer, and when you subtract them, you're going to get an answer of 12. Okay, so we are not going to do simultaneous equations like what most people are used to. We are going to work with what we have. So the two numbers, when you add two numbers and you get the sum of 66, okay, I'm just going to let that question so that you can check it out. It's a very interesting question. You would see that in my previous videos, I've also solved this question, but I do not want you to use simultaneous equations. Okay, I want you to use this fact that if you have two numbers and the sum of these two numbers is 66 and the difference of these two numbers is 12. So let's start by saying, okay, so let x represent one number, and the other number would be 66 minus x. So what we know is this is going to be the small number, and this is going to be the large number. Okay, so if I told you, for example, that two numbers, when you add them, give you 66, that's how you are going to write it. So what do we know? We know that if you take the big number, which is 66 minus x, and we subtract the small number, we should get 12. So we can remove these brackets in order for us to find what the value of x is. All right, so this is going to be minus 2x equals 12, take away 66. And minus 2x, if you now use your calculator and you say 12, take away 66, you get 54 as an answer, negative 54. And those negatives cancel, so the value of x would be negative 54 divided by negative 2. Therefore, x equals to 27. So if 27 represents the small number, So if 27 is a small number, so that's 27 there, then the other one will be 66 minus 27, which is 39. Okay, so the numbers are, therefore the numbers are 27 and 39. And you can go ahead and you can check if you subtract those two numbers, you are going to get 12 as an answer. Right, question 4. A man is now 38 years older than his son 10 years ago. So first, let's have the son and let's say the father. Okay, so we don't know how old the son is, but we know that the father is 38 years older. Okay, we have to add. So what else are we given? So we know that 10 years ago, that means we are supposed to go in the past. So what is the son's age 10 years ago? Well, it will be x minus 10. And what will the father's age be? It will be x plus 28. That is that 10 take away from the 38. Okay, so what do we know? That we now know that he was twice as old as his son that time. So x plus 28 equals to 2 times his son's age. Okay, of course you can write in either way the 2x minus 10 on the left and so on. So you'll have x plus 28 equals to 2x minus 20. Hope you still remember that we are actually multiplying out like that. Okay, so let's collect like terms. So we'll have minus x is equal to minus 48. Therefore, x is equal to 48, which means the son's age is 48. Okay, and the father, now, because we are now interested in their ages now, this part here, the father will be the 48 of the son plus 38, and if you add that, you're gonna get 86 as an answer. Okay, so the age of the son is 48 and the age of the father is 48 plus 38 more, which is 86. So he's relatively a very old man. Okay, so these questions on money is always difficult for people. So this one is not that difficult though. You just have to read the question. A man leaves 1,800 to be divided between his wife, son, and daughter. The son receives twice as much as the daughter, and the mother receives 400 more than the daughter. So let's then say, let's just say we have the daughter. The daughter, we don't know how much the daughter receives. The son receives twice as much, that is 2x. Then the mother, I'll just say mom, the mother receives 400 more than the daughter. And they are sharing a 1,800 amongst them. Okay, so if you were to add the like parts, that's 2x plus x plus x, that's giving you 4x plus 400 should equal to 1,800. And then 4x equals to 1,800. Obviously, you know that you have to take away 400 there. So you're going to get 4x equals to 1,400, and then x is 1,400. You divide by 4, and that is 350. So 1,400 divided by 4 is 350. So each person, so if it comes to the daughter, so the daughter receives 350 Namibian dollar. The son received twice as what the daughter received. Okay, so the son receives 700, and mom, she gets 400 more than what the daughter gets. So the mom gets $750. Okay, so obviously, if you were to add these totals, you are going to get 1,800. Good. So here we go with the money questions. on coins, a collection of 21 Namibian dollar coins, 10-cent pieces, and 3 times as many 5-cent pieces, and 5 times as many 2-cent pieces. Okay, so what I will suggest you do is maybe you should make a table, okay, like so, and we are comparing 3 things. Okay, so here I'm going to say the number of coins. This one here, the first column, I'm going to have the number of coins, the number of coins here multiplied by the value of each coin, and here this is going to equal to the total value. Okay, now it's a bit small, but you'll get the idea as to what I'm doing there. Okay, let's see, what do we have? Right, so we have 10-cent pieces, we have 5-cent pieces, and we have 2-cent pieces. Okay, all right, 10-cent pieces. So I'm gonna have the 10-cent here, then there is 5-cent here, and then there is 2-cent here. Okay, so the value, this is 10, this is 5, and this is 2. And what do we know? Well, we don't know how the coins, number of coins, so we're going to say let that be X. But what do you know? We know that there are 3 times as many 5 cents, so that's 3 times as many 5-cent pieces. And then also know there are 5 times as many 2-cent pieces. So we are now going to multiply. So we multiply the first column with the second one. So this is going to give us, for example, 10x, and this is going to give us 15x, and this is going to give us 10x if you multiply the 2 columns. Okay, so to multiply these 2, you're going to get 10x, for example. So where does that leave us? Another thing that is important is that we should know that 21 Namibian dollars is equal to 2,100 cents, since everything is in cents. So that means if I add up, I'm going to get 35x equals to 2,100. So this is going to be then 2,100 divided by 35. And if you divide 2,100 by 35, you get 60, and 60. Now, how many coins of each kind are there? So the 10 cent, so you can go ahead and say, okay, the 10 cent will be 60. The 5-cent coins, they will be 3 times 60, which is 180. Then the 2-cent coins, they would be 5 times 60, which is 300. Okay, you can also actually work out the value also if you want to. Okay, so the table kind of helps. So always remember, when you get a question on these coins, the money, then you always have to make a table like so. Okay, a boy finds that he has 20 more 5 cents than 2-cent coins. There we go again. So I'm going to make a table. And I'm going to say, okay, the first column is, remember, the number of coins. The second column is the total. So this one here is the number of coins, and then it's multiplied it by the value of each coin. So just excuse me there, I had to switch off the sound of the television. Value of each value of coin, or coin, not coins, and this is going to equal to the total value. Okay, so that's what you do there. And again, you will see that we have 5-cent and 2-cent coins. So here we can say 2 cent and here we'll have 5 cents. Okay, and something else, we have $1.91 is equal to 191 cents. That is if you multiply that by 100, because in one Namibian dollar you have 100 cents. So far so good. Okay, so let us now see where everything leaves us. So first of all, the 2-cent coins, we don't know. So let X represent the 2-cent coins. And we know that you have 20 more. So 2 cents, this is 2, okay, the value of the coin. And then the second part, we have got 20 more 5 cents. So 20 more, that is X plus 20. And this is 5 cents. Okay, you can actually go ahead and put in brackets because you must multiply these two columns, for example, okay, in order to find the total value. So the total value here would be 2x, and here, well, if you multiply out, it's 5x plus 100. Okay, so you just have to create an equation. 5x plus 100 plus 2x is equal to 191. So that is 7x plus 100 equals to 191. Then 7x equals to 191. And then from there, you take away 100. So that's 91 equals to 7x. And you divide throughout by 7. And you will get 13 as an answer. So how many coins of each are there? So we're going to have the 2-cent coins. So if you go back, so we say the 2-cent coins, they are 13. Then the 5-cent coins, they will be 13 plus 20, which is 33. So this is the answer that we are looking for. All right, then question 8. So you're also welcome to pause the video and attempt to do the method that I was showing you, the one of the table method, so that it's much easier for you to be able to solve this question. Okay, all right, so what do we have here? So we have got, again, another question that is dealing with coins, and says 26 Namibian dollar consists of, you have got 50-cent pieces, 10-cent pieces, and 5-cent pieces. Okay, so let me bring my table in then. Let me bring my table in. So I'm going to have my 3 columns and 3 rows. Okay, and also, so I'm going to have 50 cent. So let me just change here. So this is 50 cent row. This will be the 10 cent row. This will be the 5 cent row. Okay. Okay. So here we have the number of coins multiplied by the value of each coin. That should give you the total value. Okay. What else do we know? So we know that 26 Namibian dollar, if you multiply that, that gives you 2,600 cents. Okay, very important that we are dealing with that question right from the beginning of the sentence. Okay, now the next up, we are going to complete our table. So you have got 50 cent here, you have got 10 cent here, here you have got 5 cent. We don't know because it says that consists of 50 cent pieces, so we don't know how many they are. So we're going to say X. But we know there are 3 times as many 10 cent pieces, so that will be 3X here. And then we also know that there are 10 times as many 5 cent pieces, so 10X. So again, multiply the 2 rows together. This gives you 50X. This gives you 30X. And this gives you another 50x if you multiply them. So you're going to add all of those things. You're going to say 50x plus 30x plus another 50x should give you 2,600. Okay, if you work it out, you get 130x equals to 2,600. And in order to isolate x, 2600 divided by 130, well, if you do that, you're going to get 20. Okay, how many coins of each are there? So we can just go ahead then and complete the story. So the 5-cent coins, they will be 20. The 10-cent coins, they will be 3 times 20, which is 60. And then the 5-cent coins, they will be 10 times 20, which is 200. Okay, and that is the solution. You can go ahead and check the value, and then you will see that the value of those coins will definitely give you $26 Namibian. Okay, if you make sure that you can do that. Okay, that brings me to question 9. The numerator of a fraction. So this is another very interesting question. So it's 5 less than denominator. So let's say the numerator of a fraction is 5 less. So we're going to say x minus 5 over x. Okay. And then we are told that if 1 is added, so if you add 1 at the numerator, then you're going to get 2 over 3. So that leaves you with x minus 4 over x plus 1 equals to 2/3. Right, so you always remember, if you have expressions, you always have to put them in brackets. And you can cross multiply, so that gives you 3x minus 4 equals to 2x plus 1. So again, that will be 3x minus 12 equals to 2x plus 2. Please don't forget that you are multiplying out by removing the brackets. So again, have your like terms together. 2 plus 12, you'll see that x equals to 14. So what does it mean? If I take this part here, that is going to be 14 minus 5 over, so let us just quickly get that correct. Even the whole thing. So if I take this whole part here, so if I take this whole part here, so I'm going to have 14 minus 4 eventually, okay, minus 5 plus 1 over 14 plus 1. So the fraction becomes 10 over 15. And if you check on your calculator, you will see that 10 over 15 simplifies to 2/3. Interesting question, that one. Don't you agree? Question 10. A man is 6 times as old as his son. So we're going to have again, we're going to have a son, and we're going to have father. We don't know how old the son is, but we know the father is 6 times as old. In 20 years' time, that is in the future, so we add 20 to the son and add 20 to the father, because both of them will increase by that amount of years. What do we know? We know that in 20 years' time, the man will be twice as old as his son. Okay, so if we calculate this, we are going to find the age of the son now. Okay, very important that you understand what I mean by that now. So it's going to have 6x minus 2x equals to, okay, that is 40 take away 20. So that's 4x equals to 20, and then x is going to be 20 divided by 4, so x equals to 5. All right, this is the age of the child now. Find the age when his son was born. So first of all, we need to find out how old is the father. So the father is 6 times the age of the child now. So the father is 30 years old currently. So when the child was born, that means no age. Okay, so you'll have to say that 30 we're going to say 30, we're going to minus 5 years. So the father was 25 years old. Very important that you understand this concept, okay? This child was born. The child was not yet a year old, so you must take away the current age of the father minus the current age of the son, and that means the father was 25 years old. Okay, question 11. Tom is thinking of a number. So let me just bring it in here. We don't know what the number is, so we're going to let that number be x. He multiplies the number by 2, and then he adds 14 to the number. He gets the same result as when he multiplied the number by 4 and subtract 8. Okay, so this is an equation, collect like terms. Okay, then you have minus 2x equals to minus 22. Okay, and then x is going to be minus 22 divided by minus 2. So the number he's thinking of is 11. Okay, so again we have another question on coins. So first I'm going to say, well, $9.60 is nothing but 960 cents. Okay, we've got 10-cent and 5-cent coins, so I'm going to have my table here. And my 3 columns. So what do we know? We are having 10-cent, then we have 5-cent coins. So this is the number of coins multiplied by the value of each coin. Then this is going to be the total value. Okay, so this is the 10-cent and this is the 5-cent. So what do we know? John has 12 more 10-cent coins. So we don't know how many 5-cent coins there are, but we know that he has got the number of 5-cent coins plus 12. Am I right? 12 more than that. Okay, so of course you can put it in brackets because we're going to multiply. So that's going to be 10x plus 120 if you multiply this 10 with this whole bracket here. And if you multiply the 5 with that bracket, you're going to get 5x. Of course, you can create an equation where you now say 10x plus 120 plus 5x is equal to 960. So that's 15x plus 120 equals to 960. So that gives you 15x equals to 960, take away 120, and that is 15x equals to 840. Okay, so too fast. Please be on the lookout. I'm pausing so that you can see exactly what is it that I'm doing there. So now the next step, you're going to take 840 and you are going to divide it by 15. So 840 divided by 15, that gives you 56. Right, find the total number of coins he has. So he has got 56 5-cent coins, and well, just going to see where I can write that one. So just going to change the color here, and so the 10-cent coins, so this here represents, this here is the 5-cent coins. So the 10-cent coins, they would be 56 plus 12. Okay, and if you add, you will see that he has 68. Okay, so these are, so when he says the total number of coins that he has, we're not done. So the total number of coins, you're going to say 68 plus 56, right? Total number of coins, I'm going to write it here. Total number of coins is 68 plus 56, which is 124. Okay, you need to answer that question. It asks you the total number of coins he has. Our previous ones, if I go back to another previous one, how this question was asking how many coins of each kind are there. Okay, also if I go back, how many coins of each denomination does he have? But this question here asks you the total number of coins, which is 124 coins. That is 10-cent coins as well as 5-cent coins. Okay, second last question. Find 3 consecutive numbers. So first one will be x, the next one is x plus 1, the next one will be x plus 2. These are consecutive numbers, okay? All right. What else are they saying? They are saying such that 3 times the first, 4 times the second, and 5 times the third should equal to 74. Okay, so we have 3x plus 4x plus 4. Okay, if you multiply out, please, I hope you see where I'm going with that. And the next one would obviously be plus 5x plus 10 should give you 74. All right, so that is 12x plus 14 equals 74. Then 12x equals 74, take away 14. 12x equals to 60. Then x equals to 60 divided by 12, which is 5. So find the numbers. The numbers will be 5, 6, and 7 respectively. And you can go ahead and check if you just want to make sure that you're on the right path, okay? So if you take 3 times 15 plus 4 times 6 plus 5 times 7, that gives you 45 plus 24 plus 35. Well, if you add all of them, you'll see that you get 74 as an answer. Then the last question, okay, we have 2 consecutive numbers. So again, x is the first one, then x plus 1 is the second one. What do they say? We know that 5 times the lesser. So the lesser number has to be the first one, okay? And the greater, okay, has to be the one that follows. So what do we know? We know that 5 times the lesser exceeds. The word exceeds means you are supposed to subtract them from each other. That means this is the lesser number, and this here is the greater number. Therefore, if you say 5 times, okay, so we need to subtract, therefore we say 5x minus 2 times x plus 1. This should give us 16 as an answer. So 5x minus, obviously now you are going to multiply out like that. So that is 2x minus 2 equals to 16. That is 3x minus 2 equals to 16. That is 3x equal to 16. Add 2 more. That is 3x equals to 18. Therefore, x will be 18 divided by 3. And first number is 6. Right. So what are the numbers? The numbers, therefore, are 6 and 7 respectively. Well, you can actually go ahead and you can also check. You can also check your solution. Okay. So when you check, your solution, you'll have, if we go 5 times the lesser, so 5 times the lesser, which is 6, and 2 times, so minus 2 times 7, that is 30, minus 14, and if you do that, you are going to get nothing but 16 as an answer. So it does, the solution just checks out. So the numbers are 6 and 7. Okay, good luck with your studies. So I'm going to start posting work during this week, and tomorrow I'm going to post a few things on integration. Now, so remember, this work is suitable for learners who are doing grade 9. So this is actually supposed to be like from grade 9 to grade 11, ordinary level. Okay, you'll find some of these questions also in your grade 9 question paper. Okay, so good luck. Please have a go at these questions. I am going to post the questions on my classroom. So the way that you do that, remember, is you go to my Google Classroom, and in order for you to go to my Google Classroom, just want to see if I have the app here. So obviously, if you don't have the app, obviously you'll go into your Google account. Okay, so let's say we just close, oopsie, this one here. Let's say you say Google. In fact, you see this little 9 dots that you have there. Well, if you have them, you'll probably also see the Google Classroom app. And the Google Classroom app, I'll be going into my classroom, and I'll be uploading this also. So you can go to my grade 9, 10, 11. So I'll obviously go into the grade 9 or the grade 10, for example. I'll say grade 10. Okay, and I'm going to add, you'll find also a lot more work there. Okay, all right. So also, if you wish to join the classroom, okay, just see if I can give you, there is a code, and the code for that classroom is here. Can you see that? It's TZ53MMI, and I will definitely allow you to then be able to check out things on my Google Classroom. All right, so the work that I've done, I'm going to upload them onto the Google Classroom, and you will be able to get that link there. Okay, and also you'll be able then to download the worked out document when I put it up there, and also yeah, it's going to assist you quite in a lot of ways. All right, so I'm going to upload it onto the Google Classroom. I'm going to have the one that is not worked out as well as the one that is worked out, in order for you to follow the work that I'm doing. Okay, good luck.